Number 9 is an application of quadratics. So we have the University of Arkansas wants to construct a balloon arch for its football team to run through prior to each game, and they've designed an arch shaped like a rounded capital letter A. The curved part can be modeled by this equation. The crossbar can be modeled by this equation. So draw an accurate graph of the shaped arch. We may need to do some work before we can find all the important points, but we can at least sketch what this looks like. So this is the arch. There's a crossbar so that it looks like an A. And we're supposed to write the equation in graphing form. So we need to figure out the vertex of this arch before we can write it in graphing form. So using the formula, negative b over 2a, this will be negative 48 over 2 times negative 3, which is 8. And then the y value of the vertex will be negative 3 times x squared plus 48x minus 144. So negative 3 times 64 plus 48 times 8 minus 144, that will give us positive 48. So our vertex is at 8, 48. I'm going to go ahead and label that here. And then I also know this line was y equals 21, just so I remember the equation of that line. And I can write it in graphing form because I know a equals negative 3, x minus h, so that's 8 squared, plus k, so plus 48. What is the vertical distance from the crossbar to the highest point of the arch? We're looking at vertical distance. I know this is at y equals 21, and I know this is at y equals 48. So the difference between those is 27 feet. From end to end, how long is the crossbar? So from this point to this point, we're finding this horizontal distance. If I can figure out what the x values are at these 2 points, then we can subtract and find the width. So we can do this on the graphing calculator. I'm going to show algebraically how to do it in case you don't have a graphing calculator that you're using. On a graphing calculator, you can go to the table or the graph and find where these 2 points are. Algebraically, I know y is 21, so I'm finding what x would be equal to when y equals 21. So setting that equal to 0 makes the negative 144 become a negative 165. And then just to deal with smaller numbers, I'm going to divide everything by negative 3. This should be an x here, so minus 16x, and then negative 165 divided by negative 3 is positive 55. This is factorable. I could use negative 11 and negative 5. So zero product property gives us that x is either 5 or 11. So on my graph, I can label this point as 5, 21 and 11, 21. So now you can see that the width is 11 minus 5, or 6 feet.